So my argument is that it is exceedingly unlikely, more than that, that you would ever have a viable sexual 46 chromosomed individual, one, and the chances of having two of them together in the same place of reproductive age, and them going forward to not only produce one viable offspring, but in fact for them to go on and produce the entire human race is so small that it beggars belief. Now, bear in mind also that these 46 chromosomes, that's 23 paired individuals, are sufficiently different that, as far as I'm aware, in genetics, it wouldn't be possible for them to interbreed again with their forefathers, not direct forefathers, but their own community. Having a different number of chromosomes, how would they interbreed again? So they would be, I imagine, put me right if I'm wrong, but I would imagine that they would be regarded as being sterile, except for if there was another 46 chromosomed individual with exactly the same telomere-telomere mutation on, from chromosome 2 and 3, the connection, they would be sterile. So what the thing that makes my skin tingle is that at that point, when that chromosomal aberration occurred, we looked at, in one generation, going from ape-like animals to human-like animals, and that's really something. We stopped being ape-like with 48 chromosomes and became human-like with 46 chromosomes. And if I'm right, that all humans on Earth actually have 46 chromosomes and not 48, then how is it that the whole of the human race has been established from this exceedingly unlikely pair, however many hundreds of thousands or millions of years ago it might have been, and that they've spread their own offspring from just two people, like Adam and Eve, has spread across the whole world? So I'd invite any particularly informed comment on this. I'm especially interested in the likelihood of the telomere-telomere mutation forming a stable union of chromosomes. Any statistics that are to do with the formation of that chromosomal aberration, and any information regarding the likelihood of that producing a viable individual, and whether or not that could have interbred with the normal stable 48 chromosomes, 24 pairs. Any ideas? Because if this is true for human beings, having our 46 pairs of chromosomes, and the apes having their 48, us being distinct, what about the other animals? When did they make that chromosome step? And if it is the case, say, that all horses, apart from wild horses, I understand they've got different number, if all regular horses have the same number of chromosomes, did they have a common ancestor too? And when I say common ancestor, I'm talking about a pair of individuals. If humans had evolved from ape-like creatures in remote locations around the Earth, and this telomere-telomere mutation had occurred in isolated areas, to isolated groups and communities, how would it be that it would be on the same chromosome? How would it be? I can't see that. It might be on another chromosome. So some food for thought. Thank you for listening.